Hello class, my name is Sachin and I'm here for a small problem solving session that we are going to conduct for GMAT Quant. Okay, let's get started. Now we are going to look at three questions of a kind known as data sufficiency problems. In these types of questions, a question is asked and two statements are given. You have to answer whether the question can be answered using A, only the first statement, which is sufficient, but the second statement alone is not sufficient to answer the question. B, if the second statement alone is sufficient, but the first statement cannot answer the question by itself. C, if you need both the statements together to answer the question, but neither statement alone is sufficient to answer the question. D, if either of the statements can be used to answer the question. And finally, if both statements taken together are still not sufficient to answer the question. Okay, great. So let's start with the first question. Let's see what this tells us. T is equal to $6.8 AB8. Now this AB8 is cents, okay? So we have basically $6.80 something cents, which the person giving the question has not told us. He has given us some clues. If A and B denote the hundredth and the thousand digits respectively of the sum of money T, what are the values of A and B? Great. And we have additional two statements given, which is the data which we'll be using to answer the question. If T were rounded off to the nearest cent, the result would be $6.85. What is rounding off a number? Rounding off a number means, wait, let me write it down. Reducing the number of digits in a number while maintaining the closest approximate value of the number. I'm sure you people have already studied this in class, but let's just refresh the concepts so that it'll be clearer. I'll give you a few examples of rounding off. Suppose we have 7.6 and we need to round this off to the nearest integer. What would be the answer? 8. That's correct. So 7.6 can be rounded off 8. 7.4 would be rounded off to 7. Now we can round off these numbers to the degree, so to speak, or accuracy to which we want. For example, suppose I tell you I want to round off 88 to the nearest 10. What would be the answer? Which is the closest 10 to 88? 90. Suppose I want to round off 88 to the nearest 100. Which is the closest 100 to 88? Obviously 100. Now what this tells us is that we can round off the number to any degree we want. Okay. Now similarly, some more examples. 2.37. Suppose I have 2.37 and I want to round it off to the nearest tenth. It would make it 2.4, right? 2.33 rounded off to the nearest tenth would become 2.3. Now suppose I have 2.374 and I want this to round off to the nearest hundredth, which is the second digit after decimal. It would come to 2.37, right? Suppose I want to round off 2.37 to the nearest tenth, it would come to 2.4, correct? Okay, great. Now let us tackle the question. T equal to 6.8 AB8 dollars. Cool. What does the first statement tell us? If T were rounded off to the nearest cent, the result would be $6.85. Okay. Now note that the tenth refers to the first digit after decimal. So here the 8 refers to 10 cents or a dime. The hundredth, which is the second digit after the decimal, corresponds to 1 cent. So A here is in cents. Then what will B be? B will be 1/10 of a cent. So when the first statement tells us that T is rounded off to the nearest cent, effectively he is rounding off to the accuracy of A. Okay, let's go further. Now let us ignore $6 because we are only dealing with the decimal part here. So basically we have 0.8 AB8 and the first statement tells us that this is rounded off to become 0.85, right? Note A can only have a value of 4 or 5. Why? Because only if A is 4 can the number be rounded off upwards, shooting off upwards to form 8.85, or if it's 5, that is 0.85B8, then it can be decreased to a value of to reach a value of 0.85. So A can only be 4 or 5. Okay. So suppose we have, let's take A as 5, 0.85B8. What are the possible values of B that can be used to fit in here? We can have 0.8518, which will reduce to 0.85. We can have 0.8528, which will reduce to 0.85. Even 0.8538 will reduce to 5. And this will go on till 0.48. Moment we cross the value of B beyond 4, which would make it 0.8458, this would be rounded off upwards to make it 0.85. Suppose we have 0.8438, it would remain 0.84, whereas if it becomes 0.8458, it would become 0.85. Okay, you, you notice that there are several values of A and B that can be used here. We can have 0.8468, which would be rounded off to 0.85 if you're rounding off to the nearest cent. 0.8478 would also be rounded off to 0.85, and so on. 0.8488, even 8498, all of them would give us 0.85. 0.8518 would also give us 0.85. Correct. So you notice there are several values of A and B that can be used. We cannot find a unique value for A and B. Hence, the first statement is insufficient to answer the question. Let's look at the second statement. This is more interesting. T were rounded off to the nearest tenth of a cent, the result would be 6.85. Okay. Now instead of rounding off to the nearest cent, he is rounding off to the nearest tenth of a cent. This implies previously he was rounding off to A, now he is rounding off to B, which is the digit after A. Okay. Let's look at this statement. So 0.8 AB8 when rounded off to the nearest thousandth or a tenth of a cent is giving us 0.85 or 0.850, which is a more accurate representation. Okay, now comes the tricky part. Let us try to find values of a and b for which 0.8 AB8 can be rounded off to the nearest tenth of a cent to give us 0.85. Okay, suppose we have 0.85. Again, as I said, a can only take values of 4 and 5. Okay, 0.8518. Suppose we round this off to the nearest thousandth or the tenth of a cent. What would that give us? 0.852, right? Because 18 here, 18 has been rounded off to 2. So we get 0.852, okay? 0.8508 would be rounded off 0.851, correct? Because 08 here would be rounded off to 10, which would make it 0.851. And so on. If we have 0.8528, that would be rounded off to 0.853, correct? Or 0.8538 would be rounded off 0.854. Okay. Now none of these values are giving us 0.850. Let's look at 0.84. Let's take A as 4. Okay. 0.8488. What would this give us? 0.849, correct? Because 88 would be rounded off to 90 or 0.8490 or 0.849. Still not giving us 0.850. 0.8498. This would be rounded off to 0.85 because 98 would become 100, which would add on 1 to 0.84, which would make it 0.85 or 0.850. This is the only possible solution for A and B. Only when A and B are 4 and 9 can you round off 0.8 AB8 to 0.85. I hope this concept is clear. This is all this question has actually. Everything else is just basic. Okay. So this statement helps us uniquely find values of A and B which are 4 and 9. Hence, this statement alone is sufficient to answer the question. Statement 1 is not sufficient to answer the question. What would the answer be then? B. The second statement is sufficient to answer the question, but the first statement is not sufficient to answer the question. Answer is B. Great. Let's move on. Question number 2. What is standard deviation? Standard deviation is the deviation of a set of values from the mean of those values. I'm really never keen on too much terminology or definitions, so I'll just explain you what this means broadly. You will learn more about standard deviation in the class on statistics, but for now let me give you a brief idea of what it's all about. Mean is obviously, if you have n numbers a, b, c, d, so on till n, the mean would be a plus b plus c plus d and so on till